For hydrogen sulfide, hydrogen has 2 electrons and sulfur has 6. So we have 8 valence electrons on the molecule. Sulfur is the central atom, and you draw 2 bonds to hydrogen. This is 4 electrons, so we have to add 2 more to get to 8, 2 lone pairs to get to 8 for sulfur. So the actual structure will look more like this. The EPG for this is tetrahedral, because there's 4 structural electron pairs, and then the molecular shape is bent because you have 2 lone pairs. So the ideal bond angle in tetrahedral is 109.5. The actual bond angle will be less because it's bent. And this is a nonpolar molecule because the electronegativity difference between sulfur and hydrogen is not high enough for it to be a polar bond. Okay, this is the 3D structure for hydrogen sulfide.
So my chemical compound is chlorate, ClO3-. On the periodic table, chlorine has 7 valence electrons and oxygen has 6 valence electrons. So therefore, there's a total of 26 valence electrons since chlorate has a negative charge. The structure is drawn with chlorine as the central atom and then single bonds for all the 3 oxygen atoms. So we have Cl, single bond O, single bond O, single bond O. And then oxygen needs 6 non-bonding electrons to satisfy its octet, so it takes 18 in total to satisfy the 3 oxygen atoms with 2 non-bonding electrons on the chlorine atom, so it's a lone pair. So we have 2 here, and then 6.
What's cycloplegia? No.
Is that like a condition?
It's a condition, I just don't know what it is.
And then since the molecule has 4 electron groups with 3 bonds and 1 lone pair on the central atom, the electron geometry is tetrahedral. The molecular geometry is trigonal pyramidal because there are 3 bonds and 1 lone pair on the central atom, and so this makes the bond angle to be 109.5 degrees. And then since it's a negative charge, we put brackets around it and indicate that it's a negative charge. And that is the chlorate chemical compound. And then chlorate is polar because of the different electronegativities in the partial positive and negative charges.
This is the 3D model for chlorate. There we go. Hi, today I'm going to be focusing on the compound boron trichloride, which is BCl3. Boron has 3 valence electrons on the periodic table. Chlorine has 7 valence electrons on the periodic table. So the total amount of electrons is 3 from boron, 7 from chlorine. And because there's 3 chlorine atoms, you get a total of 24 electrons. I started off with boron as a central atom and connected them to the chlorines using single bonds. Each single bond accounts for 2 electrons. Therefore, there is 6 electrons with these 3 single bonds. And because chlorine satisfy the octet rule, I put 6 electrons for the outside of the chlorine. The electron pair geometry is trigonal planar, and therefore the bond angle is 120 degrees for each adjacent chlorine atom, and because there's no lone pairs around the central atom, which is boron in this case, the molecular geometry would be the same as the electron pair geometry. Because BCl3 is symmetrical, it has no charge difference and no net dipole, it's going to be nonpolar. Xenon difluoride. On the periodic table, you can see that xenon has 8 valence electrons and fluorine has 7. Therefore, when you add it up, you have 22 valence electrons. When you set it up, you're going to put xenon in the middle and then connect it to fluorine. Okay? And then you're going to do your valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And because xenon is past sulfur on the periodic table, you can then put
it can exceed 8 valence electrons around its circle. So you can add 6 there, which adds up to 22 valence electrons. Electron pair geometry is going to be trigonal bipyramidal, and that's because it has 1, 2, 3, 4, 5 structural pairs. And then the molecular geometry is going to be linear because these cancel each other out, so then it ends up being a straight line. Molecular geometry is linear. And therefore, the bond angle is 180 degrees. And then over here, you can see our 3D model of xenon difluoride. The same planes but going opposite directions. This molecule is non-polar. Thank you so much for watching.